Hi students, I am your physics teacher Mahima teacher. Today we will start from the chapter Electrostatic class 12th, and those who are interested, those who are preparing for NEET exam, JEE exam and board exam can follow my channel and subscribe my channel. Okay, and today we will start this topic, the electrostatics. Actually, in that plus 2, initially the charges, we are dealing with the charges, properties of charges, everything, and charges at rest. Initial few chapters are related to charges at rest, and after that charges are moving, and some other ideas about the current, electromagnetic induction, then electromagnetic waves, optics, and modern physics, and everything, and semiconductors. And the first chapter is related to charges at rest only. Okay, and let us start our topic. And in this topic, we will discuss the properties of charges, then Coulomb's law, and some problems regarding that. And if you want to follow me, please take down all the notes that I will write on this board. Okay. Electrostatics. Actually, what is the meaning of the term statics? Statics means anything at rest. Okay, and here we are dealing with the charges at rest. Charges at rest. And if we are considering the charges at rest, then only we can tell about the properties of charges. Okay, and what is charge? Actually, what is charge? Charge means it is the intrinsic property of a matter. Okay, intrinsic property. Then we already learned in 11th class that mass also an intrinsic property of matter. Then let us discuss what are the we will compare the charge as well as mass. Okay, and charge. First one, charge and mass. What are the if you are comparing charges and mass, what are the difference and what are the similarities? And the first similarity is it is intrinsic nature. Intrinsic. This is also intrinsic in nature. Okay. Intrinsic property of a matter. 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 And here also same. And charges, actually two types of charges. Positive charge, and we are representing the charge with the letter Q or capital Q. Okay. And here we can represent the mass with the M or capital M. And here the unit of charge is a coulomb, and the unit of mass is a kilogram. Coulomb and kilogram. Coulomb and kilogram. Okay. Coulomb. We can represent the coulomb with the letter C. Coulomb and kilogram. And as far as the charge, having the two types of charge, plus Q and minus Q. And here mass we can consider as only positive value. Positive value. Okay. Positive value. Positive value of mass. Always we will consider the mass as positive value. Charges, sometimes it is positive, sometimes it is a negative in nature. Another property is that charges sometimes, suppose like charges means a positive, negative, and which are repelled each other. Okay, so we can tell these charges and like charges are repelled each other, repulsive force between them. Okay, and suppose we are considering the positive charge and negative charge, unlike charges. Unlike charges means they can attract each other. They can attract each other. But in the case of mass only positive value. But we can't see any repulsive force between two masses. That means here only the attractive force exists. Only the attractive force. Only attractive in nature. Attractive in nature. Okay. Then, in order to consider the force between the charges, we will deal with another one law, that is Coulomb's law. Here, the force of attraction or force of repulsion is known as electrostatic force, and electrostatic force comes under the Coulomb's law. Electrostatic force. Here, electrostatic force. Electrostatic force. And here, what is the force? Gravitational force. Gravitational force. Gravitational force. Okay. And if you are right round, what is the electrostatic force? The force is directly, same way here the force is directly proportional to product of masses, and here the force is directly proportional to the product of charges. Product of charges, and it is a 1 by r square. Here also we can write a 1 by r square. Okay. And the charge, next we will discuss this equation in detail under the Coulomb's law. Next, charge is independent of velocity, speed. It is independent of speed of the body. Speed of the body. But mass is depending upon the speed of the body. Suppose m is the mass, we can write like this: m0 divided by root of 1 minus v square by c square. That means depending upon the speed of the body, mass can be changed, mass can be decreased. Okay, actually if the body at rest, or suppose if the velocity is comparable, if you are comparing, what is c? C means speed of light. Speed of light. And if velocity of the body, if you are telling, suppose the velocity, the speed of the bus, 20 kilometer per hour. Okay. Or that much speed, a train having 40 meter per second. Like that, if you are telling, if you are comparing that velocity with the velocity of light, it is very small quantity. If v is very small comparable to the value of velocity of light, we can neglect this. So, what is m0? m0 means it is the rest mass. Actually, in smaller classes you already learned the rest mass, but you learned the rest mass as mass of the body. Actually, the rest mass means if the mass of the body, if the velocity of the body comparable to the velocity of light, it is very less, means that mass is known as rest mass. Okay, if the mass is moving with a very high velocity, we know that the speed of light is 3 into 10 to the power of 8 meter per second. Suppose the body is moving 2 into 10 to the power of 7 meter per second, we can substitute here and we will see the mass is changing its value. That means the mass is depending upon, here independent of speed, mass is depending upon the speed of the body. Okay. Next, we will discuss the properties of charges. Properties of charges. Properties of charges. Properties of charges. The first property is conservation of charge. Conservation of charge. What is conservation of charge? You already know what is the conservation law of energy. Energy can neither be created nor be destroyed. It can transfer from one form to another form. Like that, charges also, we can't Same, just replace the word energy with the charge. Charge can neither be created nor be destroyed. It can transfer from one body to another body. Okay, that means if you are rubbing, suppose this is a plastic scale, and if you are rubbing with our hair, charges are due to, if you are rubbing means what will happen, just to do it. If you are rubbing means it become heat, the temperature rises. That means due to the thermal energy, some electrons get transferred from one body to the another body. If anyone getting loss of electron means that body become positive in nature, and if any body get electron means that body become positive in nature. That means electrons having the negative charge, if that electrons are transferred to this body means it will get more electrons, so it become negative in nature. If any body is become positive in nature, become it is lack of electron, and if any body is said to be negative in nature, that body having more electron. That is the meaning. Okay. Conservation of charge means if another definition is total charge of an isolated system remains constant. What is the meaning of isolated system? The system which is not touching with any other system. Okay, suppose this is a one isolated system, and this system having plus 3 microcoulomb, minus 2 microcoulomb, and plus 1 microcoulomb charge. Then what is the total charge? We need to consider the sign of charges also. So plus 3 plus 1, 4, minus 2, 2. That is the total charge. Q is equal to 2 coulomb plus 2 coulomb. Okay, and suppose if I am shaking this system, okay, and after the shaking, the charges accumulated in different manner. Charges are accumulated here. It is plus 4 coulomb, and here minus 8 coulomb, and we don't know what is this. So how we can find out what is this? Another accumulation of charge also we found, but we don't know what is the charge of that portion. So this is the same system. So the total charge remains constant. That means the 2 coulomb is the total charge. That means suppose we can take this as x. Then if we are adding 3, we need to get 2 as the answer. So 4 minus 8 plus x equal to 2 coulomb. Then what is this? Minus 4 plus x is equal to 2. Then the unknown charge is 6 coulomb. Actually we can't tell the coulomb. Coulomb is a very large unit, so we need to consider it as microcoulombs or millicoulombs. So here you can replace it with 3 microcoulomb, 2 minus 2 microcoulomb, like that, and we got the answer as a 6 coulomb. That means a 6 microcoulomb. Okay, this is the property of one of the property of charge, conservation of charge. Suppose another example, if this is the one of the nucleus, and we know that atomic number and mass numbers are, the atomic number is the number of proton and mass number is the number of proton plus number of neutron, and suppose this is 20 and this one is a 40, and one alpha particle is removing. Alpha particle is removing, and we got another new nucleus, and what is number here, what is the number here. And for this purpose also we need to consider the conservation of charge. We know that the alpha particle is nothing but the helium nucleus. It is 2He4. Here 2 is from 20, 2 is here. So 20 minus 2 is the answer here, 18. That means if we are adding these two, we need to get the answer 20. And 40 is here and 4 is here. So 40 minus 4, it is the 36. This is the new nucleus having the atomic number and mass number respectively. Okay. And next property of charge is addition of charge. That we already discussed. What is addition? Addition of charge. Addition of charge means, suppose one isolated system having Q1, Q2, Q3, etc. So many Qn charges. And what is addition of charge? The total charge of an isolated system. It is the total charge of an isolated system. The algebraic sum of individual charges present on the body. Charges present on that body. What is algebraic sum? Algebraic sum means we need to consider the positive value of charge and negative value of charge. If it is negative charge, we need to find out, we need to add like that Q1 minus Q2, not Q1 plus Q2, not just adding the magnitude of charge. We need to consider the sign of the charge also. That is the meaning of algebraic sum. Okay. And next one, the third property is quantization of charge. Actually, this topic is very important topic, and you also need to mark like this. It is very important for your board exam and for your Jee and NEET exam. And quantization of charge means the total charge present on the body. Quantization means it is a fixed value. Any quantity having the fixed value, that is quantization. Quantization of charge means if the charge present on the body, total charge is Q, and Q is equal to the plus or minus NE. That is the integral multiple of basic unit of charge. Basic unit of charge. What is basic unit of charge? What is basic unit of charge? It's small unit of charge. And small unit of charge which can independent in nature, we can see the independent in nature, that is the charge of electron. Charge of electron. Electron we can represent like this, and it is equal to 1.6 into 10 to the power of minus 19 coulomb. That is very small quantity, 10 to the power of minus 19 coulomb. Okay. And what is integral multiple? Integral multiple means we can take the n as 1, we can take the n as 2. That means we can multiply the basic unit of charge with the whole numbers 1, 2, 3, 4 like that only. Okay. And if we are considering the n is equal to 1, what is the charge Q? What is the charge Q? If n is equal to 1, charge is equal to plus or minus E, which is equal to 1.6 into 10 to the power of minus 19 coulomb. Plus or minus, okay. Plus or minus. Plus means for proton and negative means for electron. N is equal to 2 means Q is equal to plus or minus 2E, which is equal to plus or minus 3.2 into 10 to the power of minus 19 coulomb. And n equal to 3 means Q is equal to plus or minus 3 electron, and which is equal to plus or minus 4.8 into 10 to the power of minus 19 coulomb. Okay. N equal to 4 means Q is equal to plus or minus 4, electron is equal to plus or minus 6.4 into 10 to the power of minus 19 coulomb, like that. Okay. We will discuss another thing, another problem related to this. Suppose the charge Q is equal to 3.2 into 10 to the power of minus 20 coulomb. Is it possible or not? Is it possible or not? Or not? That is the question. How we will check? We know that Q is equal to plus or minus NE. N having the value 1, 2, 3, etc. Or 0 also, 1, 2, 3, etc. If no charge means 0 only, Q is equal to 0. So, what is, we need to find out what is N for this. How we can find out? Just divide it with the E. 1.6 into 10 to the power of minus 19. And this one, it is 2. And this 2 into 10 to the power of minus 20 plus 19. It become minus become positive. So it is 2 into 10 to the power of minus 1. That means 2 by 10, which is equal to 1 by 5, which is equal to 0.2. Fraction. N is a fraction. No, we can't tell it is the total charge present on the body, because we need to take the N equal to 1, 2, 3, 4, 5, 6, etc. Not a fraction number. We don't want any fractional number. We can't take N as a fractional number because we know that the number of charge, number of persons, we can't tell 1 by 2 persons. 1 by 2 person will come. 1 person will come. We can't take the number as fractions, fractional numbers. We can't take fractional numbers. Okay. Next topic, our topic is Coulomb's law. What is Coulomb's law? Suppose if charge Q1, this is the charge Q1 and this is the charge Q2, which are separated by a distance from the center of the charge to the center, it is R. What is R? R is the line joining from center of the charge to the center of the another charge. Then the force of attraction or repulsion, we can represent it is repulsion or attraction. Suppose these two charges are like charges, means repel each other, unlike charges means attract each other. So the force of repulsion or attraction between the two charges is proportional to the product of charges and inversely proportional to the square of the distance between the charges. This is the law. If the force of attraction between the point, these charges are point charges. What is point charge? Point charge, point body. What is point charge or point body? Point charge or point body means if we are comparing the size of the charge compared to the distance, we can take it is a very small. So this is a 2 meter and this body size is very millimeter in size. So we can tell these bodies are point bodies, point charged bodies. Okay. So the force of attraction between the two point charged body, it is proportional to Q1, Q2 and inversely proportional to 1 by R square. So this is the inverse square law. Inverse square law. That means this Coulomb's law following the inverse square law. And if we are combining these two values, these two, we will get like this Q1, Q2 by R square. And if we are removing this proportionality, and we will get a constant Q1, Q2 by R square. And what is that constant? Constant is equal to 1 by 4 pi epsilon 0, and its value is 9 into 10 to the power of 9, 9 into 10 to the power of 9 Newton meter square per coulomb square. This is the value. Then what is epsilon 0? Epsilon 0 is the permittivity of free space. Permittivity of free space. Free space. That means these two charges, the Q1 attracting the Q2 and Q2 also attracting Q1 in the same manner. And if any medium, anything present in between these two charges, it will restrict that lines of force. It will not allow Q2 to attract Q1, Q1 to attract Q2. That term, which is opposing the force of attraction or force of repulsion between the two charged body, is known as the permittivity of free space. And if it is a medium, we can tell it is a permittivity of the medium. And write down, take down, just pause the video and take down the notes. Okay. So the equations we can write like this: F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Q1 Q2 divided by R square. Okay. And if it is in the free space, if epsilon 0 is there, means it is air or vacuum. Air or for air or vacuum, or it is free space. Okay, no medium between the charges. And if it is a medium means, F is equal to 1 by 4 pi epsilon 0. Instead of epsilon 0, it is the permittivity of the medium, and Q1 Q2 by R square. Okay, one for the force of attraction or repulsion between the two charges kept at the free space, and another for kept at the medium. And these are the two equations. And if we divide these two terms, F air divided by F medium, we know that Q1 Q2 R square both cancelled each other. Only these term 1 by epsilon 0, 1 by epsilon m, which is equal to, we know that 1 by epsilon 0 into epsilon m into 1, and epsilon m divided by epsilon 0. And what is that? Another term I will introduce, that is epsilon r, that is the relative permittivity. Relative permittivity. What is relative permittivity? Relative permittivity means permittivity of the medium with respect to permittivity of the free space. Permittivity of the medium divided by permittivity of the free space. So here Em divided by epsilon m divided by epsilon 0, that is nothing but epsilon r. We can write like this: F air divided by F medium, and which is equal to epsilon r, relative permittivity of the medium. If we know the value of this and this, we can find out what is the relative permittivity of the medium. Okay, and we will do some problems also related to this. Suppose these are the two charges Q and Q, and which are kept at a distance r. And if we got the value, the force value F, the value of force as F, and Q we reduced the distance r by 2, then suppose the value of F is F dash. What is the ratio between F and F dash? F and F dash. What is the ratio between F and F dash? That is a question. Then F 1 by 4 pi epsilon 0 Q square divided by R square divided by 1 by 4 pi epsilon 0 Q square divided by R by 2 square. Okay, these two cancelled each other. Q square by R square into R by 2 whole square divided by Q square. Q square, R square cancel, 1 by 4 is the answer. That means F by F dash equal to 1 by 4. That means F dash equal to, just cross multiply, F dash is equal to 4 times of force. Okay. And suppose if we are kept this arrangement in a liquid, we are keeping this arrangement inside the liquid, and liquid having the relative permittivity as epsilon r. And what is epsilon r? That is the question. Suppose the force is at 4F. Then what is the epsilon r value? We know that F air divided by F medium equal to epsilon r. F air is a F. Suppose this is a 4F. We got it is 4F. F by F epsilon r. Then what is epsilon r? Epsilon r is a 1 by 4. And suppose they are asking is the permittivity of the medium. How we can find out? We know that epsilon n divided by epsilon 0 is equal to epsilon r. So what is this? Epsilon r 1 by 4. Then Em epsilon m equal to epsilon 0 divided by 4, because 1 which is equal to 1 by 4. Just cross multiply to this side. Then epsilon m is equal to epsilon 0 divided by 4. What is epsilon 0? We need to find out what is epsilon 0. We know that 1 by 4 pi epsilon 0 equal to 9 into 10 to the power of 9. And if we are calculating from this, we will get epsilon 0 as 8.85 into 10 to the power of minus 12 Newton meter square per Coulomb square. Okay, next problem. Suppose, next question. Please read this question. Two identical balls, each having a density rho, okay, are suspended from a common point by a two insulating strings of equal length. Both the balls have equal mass and charge. In equilibrium, each string makes an angle theta with the vertical. Now the balls are immersed in a liquid. As a result, the angle theta does not change. The density of the liquid is sigma. Find the dielectric constant. That means initially they hang from a point and it repelled like this, and one of the string make an angle theta with the vertical. Okay. And suppose this arrangement is immersed in a liquid, then also they are repelled each other. with the same angle theta with the vertical. Okay. Suppose, and this is totally if you are considering means it is 2 theta. Angle between the two string means it is 2 theta. One of the string make an angle with the vertical is theta, half of it. And we need to find out what is dielectric constant of the liquid. Okay. First take down and try it. Pause the video and try it. Okay. We will discuss. The liquid density sigma, density of the ball rho. Okay. Initially, this is the arrangement. And one of the string make an angle theta. Okay. And this is the tension. And if you are considering this is the angle theta. What is this? T cos theta. And what is this? T sin theta. T sin theta in this direction, T cos theta in this direction. We know that these two balls are repelled each other, so repulsive force in this direction. And what is this direction? This is the direction of weight. So just balance the equation. T cos theta balance with the mg, repulsive force balance with the T sin theta. So F is equal to T sin theta, mg is equal to T cos theta. Just divide these two equations. F by mg equal to tan theta. Okay. F by mg is equal to tan theta. This is the force in air or free space. And suppose this arrangement is kept immersed in liquid, then also it will make the same angle. Here the force or repulsive force, and here also same way tan sin theta, tan cos theta, mg. But this is inside the liquid. So we know that liquid will exert an upward force, buoyant force, and buoyant force having the direction like this. This is the buoyant force. Buoyant force we can FB. It is the buoyant force. Buoyant force and the T cos theta in the same direction. So just balance these equations. T sin theta equal to F T cos theta plus FB equal to mg. Bring this to this. So T cos theta is equal to minus FB. Divide. Then tan theta. Tan theta here F divided by mg minus FB. What is FB? It is the buoyant force. We know that the buoyant force is equal to volume of the sphere and density of the liquid into G. This is the equation. And what is mass? M here. M is equal to, we know that mass is equal to density into volume. Density of the sphere is rho. So rho into volume. And substitute here. This is the force in medium. Okay. Then substitute in this equation. So we will get F medium divided by V rho G minus V sigma G. and equate this tan theta, this also tan theta. So both are same. So we can write F air divided by mg equal to F medium, that is liquid, V into rho minus sigma. Okay. Then bring the mg to this side. So mg Fm. We know that mg we can replace with the V rho g, and Vg cancelled each other. So rho by rho minus sigma. What is Fa divided by Fm? Fa divided by Fm, that is we know that yes, sigma. Suppose these arrangements, suppose they are telling these arrangements are repelled by an angle 60 degree, and the sphere of density point 1.5. Suppose it is 1.5, and the angle is 60 degree, and the same arrangement kept immersed in a liquid, then with the same angle 60 degree, and the density of the liquid is 0.5. What is the angle? 60 means it is 30 degree, and sin 30, so t sin 30 equal to f. Instead of theta you need to substitute the total angle is 60, half of the angle 30, but no need to find out all this. If you are by having this equation, you can solve easily. Okay. In this video you learned about what are the properties of charges, Coulomb's law, and relative permittivity of free space, everything, and repeat to see the video and pause the video and do the problem, and every time revise the same topic very well. And if you have any doubt, you can ask in comment box, I will reply. Thank you for watching my video. Bye.